This is Precalculus Concept 19D. We're going to be looking at how to graph a logarithmic function. There are four boxes. We're going to start off with an example here, and we're going to see if we can come up with the graph of the function f of x equals log base 2 of x. Well, it turns out what's going to be really helpful here is to think about the inverse function. And from your last lesson, hopefully remember that the inverse of log base 2 of x is going to be the exponential function 2 to the x. So I'm going to pull up a graph of this function real quick, and then we'll go back and graph the original function. Alright, so we should be able to generate the y equals, or f of inverse x equals 2 to the x graph pretty quickly. We should know that it's exponential growth. We've got our horizontal asymptote here at y equals 0, and I have a couple points shown on the graph that I can pretty easily generate. So in general, it's quite a bit easier to graph an exponential function than it is to graph a logarithmic function. But now that I have this, I should remember that inverse functions are simply related because all of their x and y coordinates are flip-flopped. So I'm going to take a few points over there. The point 1, 2 on the graph of 2 to the x is going to be changed into the point 2, 1 on the logarithmic graph. So this is going to be the point 2, 1. 1, 0 will become, 0, 1 will become the point 1, 0. And then negative 1, comma 1 half, when I do the inverse, is going to become the point 1 half, comma negative 1. Also, my intercept also has the x and y flop, so instead of y equals 0, this function will have a vertical asymptote that's going to be x equals 0. So when I put all that together, I get a new graph that's going to be my logarithmic graph. It's going to look like this. It's got corresponding points that are simply just the x and y coordinates switched. So in general, if you're asked to draw a specific logarithmic graph, you may find it helpful to graph the inverse exponential graph first. Alright, just like with exponential functions, there's some things about a basic logarithmic function that are similar no matter what your base is. So I have three graphs shown here. In the red we have log base 2 of x, blue is log base 5 of x, and the green one is log base 1 half of x. And you can see they're all a little bit different, but they also all have some similar properties. Let's start off with the domain just by looking at the graph there and keeping in mind I have an asymptote here, just like in our last problem. The domain is going to be values that are bigger than 0. X is bigger than 0. When you look at the range of each and every one of those graphs, you should realize that it's all real numbers, so every logarithmic graph will have a range of all real numbers. Intercepts, if you look carefully, there is no y-intercept because of that asymptote, but all three of them have a common x-intercept of 1, 0. Alright, finally, if you have a base that's, but a base that's bigger than 1, like the red graph and the blue graph, you can see it's going to go up and right. And if you have a fractional base, like a half, then it's going to go down and right. Okay, and then finally the asymptote, which we kind of already talked about, is for all of these graphs, x equals 0. So no matter what your base, whether it's 2 or 10 or 5, basic logarithmic graphs will have these 6 properties. Alright, this is a you try. I'm going to have you pause the video in just a second, or it's going to be paused for you. And in your notes, I'd like you to try to do this problem. Graph f of x equals 3 to the x, and g of x equals log base 3 of x. Remember, those are inverse functions. Do them on the same axis and see if you can label 3 points on each graph. Take a couple minutes to do this before you move on in the video. Alright, you should have come up with something like this. You have the exponential graph 3 to the x shown here in red. You might have had some other points, but I picked 0, 1, 1, 3, and 2, 9. And then in green, I have the logarithmic graph, log base 3 of x. Notice that the corresponding points are 1, 0, 3, 1, and 9, 2. The exponential graph should have a horizontal asymptote. You see that here, y equals 0. And the exponential graph should have a vertical asymptote of x equals 0. So again, when you're graphing logarithmic functions, it's very helpful to think of them with their inverse pair, which is the exponential function with the same base. Alright, just like with every other function, we should be able to graph inverses of a basic function. So we've got a log base 5 of x graph shown below. And again, in your notes, I'm going to ask you to do 2 different transformations. As you draw your graph, think about what happens to the asymptote and the given points. Alright, let's start off with g of x equals log base 5 of x plus 2. Do a quick sketch of that graph in your notes before you move on. Alright, we should recognize this as a transformation of a shift 2 units to the left. So my asymptote is going to be moved 2 units to the left. That's going to become x equals -2. My x-intercept is going to be moved 2 units to the left. That's going to become -1, 0. And my point 5, 1 is going to be moved 2 units to the left. And that's going to become 3, 3, 1. Right? And putting all the points together, you're basically going to see a shifted graph. It looks very similar in shape. All of the points have been moved to the left. Okay, try the second one. What is the graph of negative log base 5 of x plus 1 look like? There's 2 transformations there. Give it your best shot. Alright, since there's 2 transformations on this one, I'm going to do it in stages. So the first stage, if I have a negative out in front of the function, remember that's going to reflect things through the x-axis. So I'm going to show this 5, 1 point changing to 5, -1. This is the intermediate graph. If we reflect everything through the x-axis, it should look like that. And then on top of that, I have to move my graph up 1. I'm going to do my final graph in red. I'm going to move this point up 1. I'm going to move this point up 1, and every other point I'm going to shift up 1. This is what the graph would look like. It should go through this point over there. Let me try that again. Down through that point and through that point. Hard to be super precise here, but you get the idea that I'm taking my original graph, I am flipping it through the x-axis and shifting it 1 up.